Hey there, in this video we are talking about structures and member access in C++ programming. And this covers sections 11.1 to 11.3 in the Gaddis C++ book. Now as a reminder, we just got done with chapter 10 in which we were reflecting on the status of strings in programming. And the thing about strings is they're really built out of a more fundamental data type that's built into C++, namely the character data type, the chars. A string is really a bunch of chars put together in a way that's interesting to us because then we can use it to hold names or cities or things like that. So we're building on that theme here in this chapter 11. The main idea here is that you can define your own new data types by putting together any kind of fundamental data types, any types of data that already exist in C++. You can package them together any way you want that's interesting or useful, and you will have a new fully formed data type, just like an int or a float or a char. So this is very interesting and very useful here. Common to any programming language, might be called something different, but in C++ we call them structures. So here we'll be combining data, any data that we want, into structures. A structure is a C++ construct that allows multiple variables to be grouped together, and that'll be super, super handy. So the general format is that there's a keyword in C++ called struct, which is short for structure. You give it some kind of good name, and then you'll have curly braces. And inside the curly braces, you can define whatever types of data this needs to have. So you'll have a first type, maybe that's an integer called length. And maybe the second time will be a string called name, and whatever types and whatever identifiers you want to use for the data that's being packaged together in this struct. Now, this idea, again, we inherit from the C language. So if you're doing this in C, it's the exact same thing as this. If you're doing this in Java now, that idea is called a record. And I would say that probably in a lot of other types of software, you call this a record. Database programming, spreadsheets, other types of software, commonly called a record. But here in C and C++, we call this packaging of several pieces of data. We call this a structure. So here's an example in a couple sample programs in the book, I think. We have a struct that is called student. So this supposedly has all the data you need to handle a student, maybe in a college registrar's database or something like that. The name of the structure is technically referred to as the structure tag, right? The literal name student. Now, this particular structure has been defined with 4 members. These are your structure members. And you can see there's an integer to hold the student ID. There's a string to hold the name, pretty common. There's a short integer for year in school. And then there's a double precision floating point value for GPA. Of course, GPAs have a decimal in them, so that makes sense. Don't forget about the short integer type. We reviewed that at the beginning of the semester. Remember, a short integer only uses 2 bytes, so it's good for shorter numbers, smaller numbers, and saves you some space. And of course, the year in school is probably going to be 1, 2, 3, or 4, or maybe 5, 6, possibly something like that. A very small number, so you might as well save some space and use a short there for that. Now, a couple things to emphasize about this is notice that the type name, right, the structure tag, really the new type, starts with a capital letter. That is customary styling for C++. And if you remember, everything we've talked about in the course, up through chapter 1 through 10, we said you're going to make your identifiers start with lowercase letters. That's how you indicate a normal variable in standard styling. The reason we were saying that is that we wanted to wait until today, until this slide right here, to leave aside starting with a capital letter because we use that to indicate a new type. So we distinguish those two things, and if I see an identifier that starts capital, I immediately know that's a new type. But if I see something that starts with a lowercase letter, I know that's a normal variable identifier. Okay, so here we are actually using capital letters to indicate structure tags, and the rest of it we would do camel case like normal. Notice that the structure definition does end with a semicolon, so you need that. You could put multiple fields on one line. So maybe you could write a string, first name, comma, second name, comma, city, perhaps. If you have multiple members of the same type, you can put them together like we normally do with commas. So a couple different options around there. But the main thing is you made a new type. So now right, having done this, in addition to having ints and floats and chars and bools and strings in your system, you also have type student in addition to those things. So that's the main theme here, and we'll probably touch back on that again. But that is what just happened. A very interesting thing that just happened is you just made a new type. Okay, so when you have a type, right, that doesn't really do anything. A struct declaration does not allocate memory or create variables. It just creates a structure, right, a defining blueprint for how you could declare variables. So now that you have a type, you'll have to declare variables of that type just like you do with an int or a float or a char. So here we are using the structure tag as a type name, and I could write in student stu1. And now I've just declared a variable of type student. The name of this variable is stu1 for what it's worth. And now something has been put into the memory system, is this package of variables called stu1. And inside that package, of course, there's an integer for student ID, and there's a string for the name, and there's a short int for the year in school, and there's a double for GPA. And initially, all those memory locations would have random garbage, but then we could start assigning information into those locations and use them for storage. Okay, so kind of interesting how just one little line of code now really made 4 different memory locations for us to use. So we're getting a little bit more efficient with our programming. That's the declaration, I would call that. Now, once you've done that, how do you get at those independent fields, those independent members inside your structure? You're going to start seeing the dot operator used a lot for that. So what you do is you name your variable and then dot, or period if you like, and then after the dot, you name what member you're interested in. And then you can just use that like a normal variable. Okay, you can assign that variable, you can count it, you can syn to it, you can pass it to a function, whatever you want. So a couple of examples here. Here we are using syn into the member stu1.studentID. Remember, that's the integer field holding the student IDs in a student structure. So stu1.studentID. Put that together, that's an integer. Here we are using getLine. Like when I get somebody's name, I probably want to get it with a space. So I can't just use syn arrow, I have to use getLine. So here we are using getLine, syn, and putting their name into stu1.name. And then here we are assigning their GPA at some point, and it's an assignment statement into stu1.gpa. So in each case, we've named the structure variable dot, and then what member you want. So you're kind of digging into more detail after the dot. And we've synned into one field, and we've getlined one, and we've assigned one. And again, they're just normal variables, so you can do whatever you want. Right? Member variables can be used in any manner appropriate for their data type. So integers, strings, floats, do whatever you want. You're going to see a lot of dots in your programming starting now. So here is the very first program for an example in chapter 11 of the book. This program demonstrates the use of structures. So you notice that your structure definition, your new type definition, probably has to be about the first thing in your code file. Or it could be in a header that you're including. I mean, that's a lot of what's happening with your inclusions, actually. But here in this program, they're defining a structure called payroll to hold all the information that a company needs about a particular employee and how much they're getting paid or how much their check is being cut for. So the structure is called payroll. You can see it has several members. It has an integer for the employee number, right? Emp number for short. It has a string for the person's name. It has a double float for the numbers of hours that they worked this week, a double for the pay rate, how much they get paid per hour, and then a double for the gross pay that their check is going to get cut for this week before taxes. So there's your structure definition. And now there's a main function that goes on to the next slide here. The very first line, line 18, right? We are declaring the data. It's one single payroll variable, and it's being called employee, right? So look at line 18 very carefully. And sometimes I would ask my students, there's a variable there, what type is it? It's not an int, it's not a float, it's not a char, it's a payroll, right? That is the type of this variable employee. And so having declared that data, and you know, in prior programs, we'd probably have to have several lines of data declaration, right? You'd have to declare one thing for the name, one for the employee number, one for the hours. But here, it's just one single thing. And that one single structure is going to package together all the data that we're really interested in. So in some ways, this technique is making our code a lot shorter. So having declared the data, now you're going to have the input part, of course, and we prompt for the employee's number, and we send that into employee.emp number, right, and get the employee's name. So prompt for that, and of course, this is where we have to use getLine to get the employee's name into employee.name, of course. There we go. Now, there's a little bit of a detail there on line 26 that you're going to want to be careful about in your upcoming assignments. And there's a little bit of an awkward disconnect between using sin arrow for input versus using getLine sin for input. You're both are pulling characters out of the keyboard buffer. Okay, that's great. From the sin object into some variable. The awkwardness is that the sin arrow reads up to a new line character, like if you hit the enter, but leaves it in the keyboard buffer. On the other hand, getLine reads up to a new line and takes it out of the keyboard buffer. So the way that getLine works is it assumes that there's still a new line, or the other way around. getLine assumes there's no new line at the start of its input. So if you're transitioning between sin arrow input and then you want to do a getLine, you have to manually pull the new line out of the keyboard buffer. Okay, that's what's happening on line 26, doing sin.ignore, taking one more character out of the keyboard buffer, namely the new line that the sin arrow left there, and now you're set up to properly use getLine. Okay, so you're going to think about that in future programs. I wish that wasn't the detail we had to deal with, but if you transition between sin arrow input and getLine input, you do have to use that sin.ignore to make it work right. So look for that in other examples in the book, and think about that if you're a student in my class. That's probably going to happen on your next assignment, probably. Anyway, not the most important thing, but a little detail to keep in mind. So the other input, of course, you sin in the number of hours into employee.hours. That's really what we're focused on, the member access in this employee variable. You get the hourly pay rate, and you send that into employee.payrate, of course. Now comes the processing part of the program, calculating the employee's gross pay. I would also like to fill in that member variable for gross pay. So I'm going to have to assign into employee.grosspay the result of employee.hours times employee.payrate. So again, each of these things is an independent double variable. So you're looking up employee.hours, right, getting that number, looking up employee.payrate, getting that number, multiplying them together, and then assigning the result into the member variable employee.grosspay. So like we said, going to be a lot of dots running around as you access these individual members. Now comes the output part, and you're going to be seeing more dots. Here is the employee's payroll data, and you print out name, of course, a label. We never just print raw data. You print out employee.name, and then you print out employee.emp number, you print out employee.hours, and employee.payrate, and then finally, after some set precision, the gross pay employee.grosspay. So pretty good initial example of defining a structure, right? Declaring one single little variable of that type, and then doing input into the members, using the members for calculations like this gross pay calculation, and then also accessing the members for output. And you'll want to do that a lot. But how nice it is that we just had to declare one single thing to store all this data. And that's what a structure gives you. Okay, so let's test this program 11.1 here. Again, get your structure definition here. And among the new interesting things is on line 18, declaring one single variable. What type is it? It's not int, it's not float. You get the idea. It's of type payroll, and it's a package of all this other data. And at that point, we got the input, we got the processing, the output. So let's test that. Compile it. Of course, that works. And now I'll run it. Maybe just once. So enter the employee's number. How about 3456? Enter the employee's name, maybe Alice Smith. Notice the name has a space. That's why you have to use getLine for this name member, of course. How many hours did the employee work? Maybe 40. How much are they paid per hour? Maybe 20. Okay, so there's my input. Does some processing. Here is the employee's payroll data. Name Alice Smith. Number 3456. Hours worked 40. Hourly pay rate 20. And of course, the gross pay here is $800. So that looks like that's working correctly for me. So this actually does work to store all that data in those member fields of one structure and then access it for both processing and output at the end using the dot operator. That totally works. Let's just make sure one time that we really understand this. Let me run this in the debugger actually and see what's happening. So I guess I've got this compiled right. Okay, so I'll run this and I'll try to put this on screen so we can see both the code and the output. But the thing that I'm really interested in, and so the program is started here, we've paused temporarily on line 18, is I want to actually inspect what's in this employee variable. So I'm going to add a watch for that, right? Just one variable, employee. And we'll keep an eye on the debug tab over there on the left and see what shows up. Okay, so our debugger knows about structure variables, right? Here's a variable called employee, and it is showing us all 5 separate members, all 5 separate fields, some people would say, that's inside that variable. So it's in a little, tab, a little indented here to show that that's really owned by the employee variable. Of course, as the program starts up, all those fields have random garbage in it. Some might be 0, some might not be, right? The string's got a bunch of random characters in there. So that's kind of what we'd expect. And as we go through this program, prompt for the employee's number, right, here I am on the SIN here. So maybe I'll make up a new employee here. How about employee number 5678, enter. You can see that that particular member gets the data from that SIN statement. That's pretty much what we would expect. Enter the employee's name, right? There's that little detail about getting rid of the new line that the SIN on line 22 left in the keyboard buffer that would cause trouble for a get line statement. Right, that little detail we talked about. So here we're inputting this. Maybe this is Bob Smith. And you can see over in the debug tab that that gets stored properly in the name variable. And we kind of go on like that. Entering the employee's hour. Maybe Bob worked 30 hours. There we go. 30 is stored. What's the employee's pay rate? Maybe Bob makes $25 an hour. Okay, and you saw there was a little glitch there in the debug tab just for a second. It got confused, but it's back. So, so we did that, and then we did line 38. And it computed gross pay, and the gross pay got set to 750. So every field in the employee variable is now filled out with legitimate data, and you go through the output part, and all that stuff gets printed to the screen with the dot operator, like that. Great. Okay, so again, sometimes I like to, when I see a new structure in C++, I like to run it in the debugger, maybe just once, and see exactly what is being stored in memory as that works. And I hope that hopefully that visualization helps clarify that stuff. And of course, you get the return statement, and the program is wrapping up, or it should wrap up, and the program's over. Great. Oh, one other thing here. So I spent a lot of time in the debug tab, is where I have been before. But there's one other interesting thing here in Dev C++ or other IDEs that might be interesting to you, is there's this classes tab. And that hasn't been of any use to us before today. But let's click on the classes tab and see what Dev C++ shows us. Okay, so Dev C++ knows about C++. And it knows that you're going to have a bunch of separate functions, and it knows about structures. So when we first loaded up this file into Dev C++, our IDE scanned this and said, oh, you have a new structure being defined in this file, and I'm going to help you out by keeping track of it over here. That payroll structure is being listed here. And if I click on this little arrow, it's going to show me all the separate fields, all the separate members in that structure, right? The 1, 2, 3, 4, 5 different members, and also what type they are. Right now over here, it's listed with the name first and the type second. And so how that's going to be really useful is if I'm working on a particular program and the program gets longer, of course, maybe I'm working down here, well, my structure definition isn't on screen in the file. And I would have maybe a little bit of trouble. I have to remember, like, well, okay, what are the members in my structure that I can access or assign to? So Dev C++ is kind of helping us out by keeping track of that in this left-hand tab, as I can just look over here and go, oh yeah, There's an hours member, there's a gross pay member, stuff like that. So you might want to start keeping, as you work with structures, you might want to start keeping the classes tab up, and that'll help you just look over here and go, yeah, that's the stuff in the structure that I'm dealing with here. And if you want to deal with something else, you can close that, of course, and then you can open up later. But I find that kind of handy over there. Now, we are not actually dealing with a class in this program. Again, we're dealing with a structure. Classes we'll talk about really later in a couple chapters, and they're kind of like structures actually with some more stuff added to them. So it kind of makes sense that structures are being shown in your classes tab. Whenever you're working on code, you really want all of the stuff that you have to mentally deal with on screen at once, right? You really want all your relevant information on screen so that you don't have to memorize stuff. And that is why we focused on small modular functions where the input parameters and the return type and all of the code are on screen at one time. So here's another method that the IDE is trying to help us out with, is I would really like to see my structure and my class definitions in sight while I'm working on that kind of thing. So that's kind of handy. And here's one other thing. Let's say I was working on code here, and maybe at this point I wanted to set the employee hours to 0 because the week is over. So I could say employee, right, I'm about to assign to 0, dot, and you notice that a little window pops up. Again, Deb C++ knows about structures and knows that if you write employee, and that's a payroll structure, dot, there's only 5 things that can come after the dot. Right after that, you must name one of the members. That's the only stuff that makes sense. So it actually pops up a little window with all of the options you have at this point. And unfortunately, graphically, that's a little screwed up on my screen at the moment. But if I arrow down, see, there's all the different 5 things: employee number, gross pay, hours, name, and pay rate. Those are the only things that could possibly follow employee dot. So I could just arrow down and pick the one that I want with enter, right? I could type it myself, of course, and then I can write equals 0. And so you might kind of keep an eye on that pop-up there. Hopefully it looks a little bit better on your screen, I hope. Hopefully it's fixed on your computer when you run this. But you could possibly use that little pop-up to save a little bit of typing and go a little bit faster by picking the thing in the drop-down list. So, and other IDEs other than Deb C++ will have features like that. Maybe they won't look exactly the same, but any modern IDE will be trying to help you out, knowing about structures and knowing about classes, what the options are, and trying to get you working a little bit more efficiently. So kind of keep an eye, whatever IDE you're working in, keep an eye out for those kinds of features. Okay, so to kind of recap what we saw in that example, remember that at the end of the program, in order to output the structure, we did have to have separate lines counting out each individual member. So to display the contents of a struct variable, you do have to display each field, each member separately using the dot operator. So maybe in another program where you've got a student structure called bill, right? You'd have to have one line that says count bill.studentID, and another one that prints out bill.name, and another line to print out bill.year in school, and another one for bill.GPA. So what this slide is emphasizing is you cannot, one of the few things you can't do with a structure is you can't just do count student, right? You can't send a whole structure to a count object and expect it to work because the count insertion operator doesn't know about your new structure. Okay, it only knows about fundamental types or pre-existing types. So, here is a place, if you do need to print out your structure, and I'm sure that you do, here's a really good opportunity for good modular programming, is you can make a dedicated function to do this for a given structure. You really ought to have one function that just prints your structure. And I guess it's going to be a future video where we point out how to pass a structure into a function and just do this one single printing job. But you can probably fill it in yourself because it works exactly like passing an int into a function as an argument. Okay, so you can probably think about how that's going to work. But certainly when you write your programs, you want to have, again, modular programs, one function for input, one function for output, one function for each type of processing, and this right here would be a good opportunity to do that. I think in the book there's program 11.6 that actually has a very good example of that. We'll see that in about 2 days, I think. But if you have the book, you could look at program 11.6 to see what I'm talking about. Okay, so that is the end, actually, of our introduction to structures, right? Hopefully it's a fairly simple but incredibly powerful idea of packaging together multiple pieces of data, and now you just have to deal with one thing. Now, before we conclude, I want to emphasize this. Structures are new data types, right? You have just done something very interesting and something very powerful is you have added a new data type to your C++ programming. When you define a structure, you have created a fully formed new data type. So in addition, right, at this point, in addition to the type int and float and char and bool and string, now you have type student, right? And every time you define a new structure, you have a new type. So the primary theme of the rest of this chapter, and actually future chapters with other stuff, is that basically anything you can do with a basic data type, you can also do with your new structure type as well. So, can I declare an int? Can I assign a number to an int? Then the answer is yes for structures as well. I'd say yes for a student. And pretty much anything else, if I ask myself, can I do this with a structure? I might ask myself first, can I do this with an int? And if the answer is yes with int, the answer is going to be yes for my structure. Can I pass an int into a function? Can I return an int from a function? Yes, yes. Then you can do the same thing with a structure. Can I make an array of integers, of a bunch of integers? Yes. Can I get the address of an integer? Can I make an integer pointer? Can I pass an integer pointer into a function? Yes, 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 yes. So you can do all the same stuff with structures as well. Everything we just said you could do with a student structure. Put it in an array, get a pointer, pass it to a function, use it as a return value. Yes, 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 yes. So if you really follow what we're saying here about having made new data types, you can almost fill in the rest of this chapter yourself for what it's going to look like. But we'll go through the details to be careful about it. And that story will continue to be the case in the future as we build even more interesting and more sophisticated data types in the future. But that's really what's happening. So sort of keep that in mind. Can you dynamically allocate an integer using the new operator? Yes. Same thing with a structure. Right, you get the idea. Okay, so probably my students would get together and we would do this first lab in chapter 11, working with basic structures. And so the goal here, not the biggest program, is to write a program that takes input for a rectangle structure. So the very first thing we would need is a definition for a rectangle structure that has fields for the length and the width. You know, that's actually very common in programming, particularly if you're doing graphics programming with windows and menus and things on the screen. You need to set that up and position it properly. So a structure called rect, usually for short, is actually very, very common. So we will make a structure like that, and we'll use it to get input from the user about the rectangle's length and width, and then we'll just output the rectangle's area and perimeter is what we're going to do. I guess if I recall correctly, I guess the structure has length and width and area and perimeter, I guess, are the 4 fields, if I recall correctly. So we'll get input for the length and width. We'll have a processing section that computes the area and the perimeter, and then we'll have an output part that prints both of those things. So, of course, in our lab code, we have halfway filled in lab files that we can just fill in the new stuff that we just talked about in this lecture. But, you can probably just do this on your own, right? If you're watching this video and you're not part of my class, and even if you don't have the book, try this on your own in C++. I bet you can do this. Define a structure like that, do some input, do some processing, do some output. That would be an actual very good exercise. But I'll do that with my students in class. So next video, we'll continue on talking about other things you can do with structures. And basically, it's stuff you can do with other data types. And we'll think about initializing structures efficiently. We'll think about putting them in arrays, which is important. We'll think about nesting them, taking a structure and actually putting that as one of the members in another structure. All that stuff you can do. So I hope you'll join me for that next time.